We are Team 3. We are Hackers Coalition, and this is our presentation for our hack project. So we have me, Adrian Luna, Ariana Aceves, Charles Zhang, and Omar Garcia. And then we split up our team into sub-teams. So Omar was more in charge of doing the coding, the API call, and the communication between the front end, back end, and the Pico and the MQTT. Ariana was more focused on doing the CAD and fabricating our product. And then myself and Charles was also focused on electrical sensors, soldering, and the coding for the sensors. So our plan was to create some headphones that would essentially hold our sensors like the temperature, humidity, light, and distance, and then a watch that would have a hole that our camera could record through or take pictures from, and the pager that would clip onto our belt that had an OLED screen in which the operator would be able to communicate messages to the agent.
So with the CAD, we have the headphones, the watch, and the pager. For the first part is the
Yeah.
creating headphones that could fit the uh, distance of the electrical component. Also creating something that was hollow to have all our electrical components fit, as well as the watch, making it hollow so the electrical components could fit, and then in the watch, the top part of the watch for a little opening for the camera to see through, and then the pager long to fit the Arduino, but the OLED extends on top of the pager.
So these are schematics for our sensors. As you can see on the left, we have our Pico as connected to basically the three sensors, the DHT, the photoresistor, and the distance sensor. Then in the middle, we have our ESP32 camera that was basically just connected to the voltage and ground, and the rest was done wirelessly through the Wi-Fi and the coding. Um, and then on the right, we have the OLED schematic, which was basically also connected to a different Pico, and using the code for the API for the website, we were able to communicate messages there. All right.
This is a sensors code. He had a photoresistor that was able to um, get an LDR value, read it, and then using some math, you're able to get the lumens. The temp and humidity. Uh, you obviously get a temp in a different type of reading, and you convert it into Fahrenheit. Um, and then the distance code, it was um yeah, you just assign pin numbers to echo and trigger values. Um, and it calls the echo to receive the signal's deflection, and it calculates the distance based on the time it took the signal to send it. Go to the next slide. For the main code, it was a front end using React hooks, where just made components that would receive information from the MQTT server and it would display it on the website. The back end, it was uh it was just basic backend. I didn't really got anything that much from the black box we received. There's nothing really to add. Um, and from the Pico too, I just grabbed all the code, put it in a file, and made it and implemented it to connect to the MQTT server and send information from the Pico to the server, which then displays it on the front end. And the ESP32 cam. Basically, it takes a picture, saves it on a folder, and there's a website where you can access that picture that gets taken, and then you send it to I sent it to the front end, and also sent it to OpenAI. Go to the next slide. Okay. Uh, and our website just was able to receive messages through Pico, MQTT's cloud server that connected the front end. It just displayed all the information. You were able to also send messages to the Pico through the front end using an input text field.
For the next part are our challenges. So our failures. We believe that our failures were that we rushed our fabrication process towards the end. We didn't have enough time to set our sensors within the physical fabrication design to test them. Um, our prototypes had very tight and awkward spaces, so it didn't allow for the electronics to work properly towards the end. And our gadgets did not end up working toward the final testing station. Our overview. Here's our overview. So as you can see, this was the prototype for the headphones, and up in the right corner is the watch with the pager. In the end, our sensors and code all function properly together before inserting into our fabrication design. So once it was in the fabrication design, unfortunately, our components were disconnected, when embedded into the product, resulting in not working. So here is our escape room finish. Since our gadgets were not functioning towards the final station, they allowed for everyone to enter the room. But in the end, we were able to find the diamond.
That's it, guys.
Uh, what we have done if we had more time. So what we would have done differently if all over, if we could do this all over again, we would dedicate time towards our fabrication. We would have committed earlier to a set design of what we wanted the gadget to be. Maybe go with a more simplistic approach for the sensors and its prototype, and give more room and slack within our design to secure wholly our components and circuits. So what did we learn from this experience? We learned that the importance of time and resource management is in engineering. The fundamentals of CAD, coding, fabrication design, and electrical components and circuits. We learned that the fabrication design is a crucial factor in engineering and that we must be managed wisely with time. Um, we also overall learned that taking a simplistic approach is far more effective and likely to lead to success.
Thank
Thank
you.
you.
Hi, I'm Charles. In this hackathon, I'm mainly in charge of the camera design, and for the camera, we use this component called ESP32. And for the coding setup, it's not that hard. And for us, is when you type in upload, the camera gonna take picture. So the only problem is the mentor. He told me that we need 5-volt power to run this camera, but we only have 3.7-volt battery, so we have to design a circuit to provide 5-volt power in order to make a camera work smoothly. So I designed this circuit by applying the knowledge we learned from the lecture, using the voltage regulator, and with a little bit of math, do some calculation. The output should be around 5 volt. So after I finish the soldering, so this is the component circuit I designed after soldering. I used the multimeter to test the output voltage is 5.16 volt. So it's not that bad. But the problem is the camera only works when it's on the table. So when I try to put the camera inside the watch we made, just somehow the flashlight turn on and the camera became super hot and it doesn't work. And this things happen over and over again. So I asked the mentor, he told us it's because somehow the circuit is short, so the flashlight turned on and it burned the camera. That's why the camera doesn't work. So I just spent like one day to try to find a way to provide 5-volt and not burn the camera, and I can put the camera inside the watch. I try to using electric tape to tape everything, but like in the end, the camera is still short. I still burn the camera. So because the time is limited, so in the end, I have to give out the original plan. So I just choose to use one single battery, a 3.7-volt battery to provide power. And surprisingly, the camera works smoothly. So That's it.